Welcome to Thriving Through Perimenopause. I'm your host, Dr. Anna Glazer, a reproductive and integrative psychiatrist and your guide on this journey to mastering midlife. In this second part of a 6-part video series, we're going to look into the science of perimenopausal hormones. And this is really important because this will help you understand the different treatment options that are available for mastering the perimenopausal transition. First, as a review, we discussed in the first video that the most impactful perimenopausal symptoms are those that affect mental and emotional well-being. Things like sleep deprivation, mood swings, cognitive changes like brain fog. That's why I, as a psychiatrist, am the one who's presenting you with this information. We also debunked the stereotype of perimenopause as aging, because truly with research, education, discussion, and treatment, we can instead move towards thriving. So let's take a look at the different science and hormonal cascades. First, you may recognize this is a graph of the normal menstrual cycle, keeping in mind that not everyone has a classic 28-day cycle. What's important to recognize here is that we have estrogen normally increasing in that follicular phase, peaking right around the time of ovulation, and then heading back down in the luteal phase. We also have progesterone, which rises in the luteal phase, and then by the end of the menstrual cycle, tapers off. Now, if you're someone who has always been particularly sensitive to hormonal changes, maybe you experience PMS symptoms or even PMDD, you are likely someone who's very sensitive to the fact that these hormones change and decrease at the very tail end of the menstrual cycle. Now, this is a very important feedback loop to understand. What you can see here is that it all starts in the brain with the hypothalamus. The hypothalamus releases GnR, the gonadotropin-releasing hormone. This asks the pituitary, also in the brain, to release 2 more hormones, LH and FSH, luteinizing hormone and follicle-stimulating hormone, which basically does what it says. It stimulates the ovary, the follicles in the ovary, to release, and that increases estrogen in the body. What's important about this feedback loop is that it changes in perimenopause. So the ovary releases less and less estrogen, which means that this negative feedback loop changes. Normally, the estrogen tells the hypothalamus and the pituitary to release less of these hormones because there's plenty of it hanging out. However, in perimenopause, since there's less and less estrogen, there's less and less of this negative feedback, which means the hypothalamus and the pituitary continue to ask the ovary, hey, come on, ovary, release more estrogen, release more estrogen. The ovary is unable to do, which is why we can often check LH and FSH in individuals who are really near that menopause date. Remember, it's one date in time, and you'll see that FSH, for example, is really high, and that helps us to understand that this feedback loop has changed because someone is in perimenopause, because the estrogen is no longer available for this negative feedback loop to be effective. The next thing I want to show you here is those 3 most common hormones, and we'll go into detail a bit more about all of them in a future slide. But what I want to show you is what happens to them in perimenopause. You can see estrogen tends to be oscillating throughout, and that's because of that menstrual cycle fluctuation that we discussed in the first slide. But then in perimenopause, you can see that it really trends down. However, and this is the important part, is that it still oscillates so much. You can see that here. And this is actually one of the reasons that I'm often asked the question, hey, can I check my estrogen levels? Will that tell me if I'm in perimenopause? And the answer, generally speaking, is no, because estrogen levels vacillate so much in perimenopause that it truly is a clinical diagnosis as opposed to measuring estrogen levels. And so what you can see here is that you can also see progesterone falls in perimenopause, and testosterone does as well, until they all kind of level off in postmenopause. This is another way to demonstrate what happens specifically with estrogen levels. You can see that in puberty, they tend to increase with oscillations, and often perimenopause is considered almost like the second puberty because, again, with oscillation, they decrease until they become much lower postmenopausally. Now, this next slide has a lot of information on it. Bear with me, we're going to go over it step by step. I know it can look confusing, but there's really some important details here. The first thing to notice is that it all starts with cholesterol. And I think cholesterol sometimes gets a bad rap. We often talk about, oh, cholesterol is bad, we need to decrease cholesterol, but it's a really essential building block for so many things in our body. And so it's the building block here for all of the. Now we'll get to the different steps here, but one thing I want to point out is that there's actually, when we say estrogen, there's actually 3 different kinds of estrogen that we're talking about. Now, the one that we're often talking about premenopausally, the one that we're talking about decreasing throughout perimenopause, is estradiol, E2, the one that is made by the ovary, that really important one. Now, we also have estriol that comes into play primarily during pregnancy because it's synthesized by the placenta. And then we have estrone, which is E1, and this one tends to be much more of a significant estrogen postmenopausally when the ovary is no longer making estradiol, because estrone is something that's also made in the adrenals and fatty tissues, and so estrone becomes more of a player postmenopausally. So it's just important to recognize when we say estrogen, there's multiple different kinds of estrogens, but usually we're talking about estradiol. So going back to this interesting cascade, we start with cholesterol, and we go to a precursor molecule. It's called pregnenolone, and from there, we can synthesize a few different molecules. We can make progesterone, which we're familiar with. We can also make DHEA and DHEAS. And the reason I point that out is because when we talk a little bit more about treatment options, one of the different tools that sometimes people ask me about is, can I take a supplement like DHEA to help with the precursor to some of these other cascades? Is that going to help me? For example, if I take DHEA, which then can be synthesized into androstenedione, look, that goes into testosterone. So is that going to help me with falling testosterone levels? That's why it's helpful to recognize this cascade. The other important piece that I want to mention is the relationship between progesterone and cortisol. With a few more steps, that's why there's a few arrows here, you can synthesize cortisol. And I emphasize that here really just to say that there's this relationship between all of the different hormones in our body, including cortisol, our stress hormone. Going back to this diagram, from the androstenedione precursor, we've made testosterone. Did you know that testosterone is what's used to synthesize estradiol? There's a particular enzyme, an aromatase, that takes the testosterone and creates estradiol. And so this is a really important cascade that I wanted to share with you, even though it's a little bit confusing at first glance, because there's so many important elements here that can influence the decisions that we make about treatment in the future. The last piece I want to mention is the role of estrogen receptors. Now, classically, of course, these are found in our reproductive organs, but they're really found everywhere else in the body. They're found in the cardiovascular system, the liver, bone, brain, so many different parts of the brain. So the hippocampus, the part of the brain that's related to learning and memory, the prefrontal cortex, that's the part of the brain that's really responsible for executive function, organization, decision-making, the amygdala, which is sometimes called the fear center, the cerebellum, which is really responsible for things like balance, and then the hypothalamus and thalamus, which do things like regulate temperature and hormones. And so you can understand how, because there's estrogen receptors in so many parts of our body, why there's so many, harking back to that first video, all of the different symptoms of perimenopause can be so systemic from head to toe, because there's estrogen receptors everywhere. So the key takeaway through all of this is that really and truly understanding these hormonal cascades and where they take place in the body helps us understand the symptoms of perimenopause, the science behind the psychology, which is essentially the field of reproductive psychiatry. And up next, we're going to start talking about perimenopausal treatment options, including hormone therapies.